Assalamu alaikum students, I'm your course instructor Dr. Mazullah Khan. I welcome you to my video lectures. This is lecture number 25, and today's lecture we will cover few exercises from chapter number 7 and chapter number 8. This is a chapter and problem 7.40. So let's read the problem. Okay. Samara, an engineer working for General Electric, invested her bonus money each year in company stock. Her bonus has been $8,000 each year for the last 6 years. Okay, at the end of year 1 to 6. At the end of year number 7, she sold the stocks for $52,000. Okay, so the bonus was $8,000, and whatever she got as a bonus, she invested in company stocks. In year number 7, what she did, she sold those stocks for $52,000 to buy a condo. She purchased no stock that year. In year number 8 to 10, she again invested the $8,000 bonus. Samara sold all of the remaining stock for $28,000 immediately after the investment at the end of year number 10. So the problem is straightforward. Samara is getting $8,000 in bonus each year. In the first 6 years, what she did, she invested all the money in buying company stocks. In year number 7, what she did, she sold the stocks for $52,000 and she bought a condo. In year number 8 and 10, she again invested $8,000 in company stocks, and she sold those stocks for $28,000 in year number 10. So the question is, let's go through the questions actually. So determine the number of possible rates of return. Okay, so if you remember, we covered Descartes' rule in one of my lectures. In Descartes' rule, what we are doing essentially, we are looking for sign changes. So let's do that. This is the cash flow diagram. If you see, the cash flow started negatively. The reason it's a negative cash flow, because this money is going out of Samara's pocket because she is buying stocks of her company. So it started negatively. The first sign change, as you can see, is here in year number 7. In year number 8, the sign changed again from positive to negative. And as you can see, in year number 10, it changed again. So the total number of sign changes is 3. And as per Descartes' rule, there may be 3 possible IRRs. Okay, and possible IRRs mean that up to 3 IRRs. Now, this part of the question says determine the external rate of return by hand using the modified rate of return. Why do we need modified rate of return in the first place? On the previous slide, as we were able to establish that in this particular situation, there may be 3 possible solutions. So as an economist, or let's say as a project manager, you're confused now. Which IRR should I use for my project evaluation and selection? Okay, so my task is to tackle this problem, and rather than dealing with 3 different IRRs, I should come up with only one IRR. Okay, one of the technique that we are using is called the modified rate of return. This is a very, very simple and straightforward technique. So we need 2 extra information. Okay, 2 extra pieces of information. One is the investment rate, okay, which is 12% here, and the borrowing rate of 8%. Now, this is the same cash flow again. The logic behind using investment rate and borrowing rate, the assumption is that negative cash flows, it is just like a deficit. Okay, so if Samara is in a deficit situation, of course she has to borrow that money to finance her deficit. Okay, so for example, let's say if in year number 1 the deficit is $8,000, okay, she will actually borrow in advance, not after year number 1. Okay, so her borrowing is actually here at t equal to 0. This is what the book suggests. In my opinion, and it's a very considered and educated opinion, that instead of borrowing at t equal to 0, Samara could have easily borrowed this money at t equal to 1. But the book uses that we have to discount all the cash flows to t equal to 0. Okay, so let's follow that method. I have tried both of them. I have, let's say, discounted all the negative cash flows to t equal to 0, and I have also discounted all the cash flows to t equal to 1. The difference is absolutely negligible. So what I would suggest, let's stick to the book's method. Okay, so Samara, what she will do, she will borrow all the deficit amounts, like its discounted value, at t equal to 0. Okay, and of course for that we are using the borrowing rate. Okay, so the trick in this question is, for PW, which rate should I use? Of course you should use borrowing rate. Okay, because Samara is supposed to borrow at t equal to 0 at the borrowing rate. Now the other assumption is that the positive cash flows, like this $52,000 in year number 7, Samara would like to invest it somewhere. Okay, and if she is investing, her return is realizable at the end. Okay, so if she invests now, she is expecting her return in future. Okay, so that's why all the positive cash flows had to be compounded, which means that we have to calculate the future value of positive cash flows. Now for the borrowing part, PW, okay, I'm using, so $8,000, as you can see, from year number 1 to year number 6. Okay, so for 6 years. Okay, I have to multiply it with the PF factor because this is annuity. Okay, and I have to calculate the present value of this annuity. This $8,000, it's actually here. Okay, so these two $8,000, I have to calculate the present value, like I have to discount it. And if you can remember from the conventional cash flow diagram, if I multiply it with a factor in which t is equal to 2, it means that these two annuities will be discounted to t equal to 7. Okay, and then I have to, of course, discount it for another 7 years to bring it to t equal to 0. So this is the way we calculate PW. This one is straight from chapter number 2, basic concepts. For future value of positive cash flows, I have to compound $52,000, which is here, okay, for 3 years, okay, and then I do not do anything with 20,000 because this 20,000 is already at t equal to 10. So my future worth of the positive cash flows is 93,055. So the whole problem boils down to a very simple setting now. So the present worth of the negative cash flow is 45,037, and the future worth is 93,055. So my task is to calculate what we call MIRR, which is the modified internal rate of return, at which the $45,377, if I compounded for 10 years, okay, the value would be 93,055. So I use this simple equation, okay, to convert present into future, okay, and if I solve this equation for I, it's actually 7.5% per year. Okay, so let me go back and show you the same thing from through Microsoft Excel. Okay, so I have punched all these numbers in Microsoft Excel. As you can see, it's okay. Let me remove this. Okay, so $8,000 up to from year number 1 to year number 6, then $52,000 after she sold the stocks. She invested $8,000 again in year number 8 and in year number 9, and then of course she sold those stocks for $20,000. So one way to calculate the modified internal rate of return is very simple. This formula is already in Microsoft Excel. So it is MIRR. Okay, once you double click on this, it says values. So choose all values. Okay, and it says comma, and then it says finance rate. So finance rate here means the borrowing rate, which is 8%. Okay, comma, and then it says reinvestment rate. Reinvestment rate is actually the investment rate, which is 12%. Okay, and once I enter, as you can see, it is 7.4, which is close to 7.5. So what computer does actually, once I input the finance rate, which is the borrowing rate, it applies that borrowing rate for all negative cash flows, okay, and discount it to t equal to 0. So computer discounts all the negative cash flows to t equal to 0, okay, at the borrowing rate, which is 8%. And then the computer does what it does, it compounds. In other words, it calculates the future value of positive cash flows and use the investment rate, which is 12% in our situation. Okay. If you would like to calculate, of course, through Microsoft Excel, it is straightforward again. Either you use formula or you go step by step. So this is the discounted value of what's this called? Sorry, let me remove this. It's not required. So as you can see here, what I'm trying to do, I'm trying to divide this number, which is $8,000, okay, and divide it by 1 plus I, which is the borrowing rate, and then raised to power 1. So I'm discounting this number for only 1 year. Then of course I'm discounting this number for 2 years, 3 years, 4 years, 5 years. And as you can see, I skipped this number because this is positive. I calculated actually the future value of this number. Okay, so I'm doing exactly the same thing as I did on one of my slides here in Microsoft Excel. So let's move forward. Now this one is a little bit technical. It is technical, but the concept is not that difficult. Okay, so again we are calculating the external rate of return. Why is it external? Because we are using outside information. Like for example, this 12% is not part of Samara's cash flow. Okay, it is coming. It is an outside information. Okay, so that's why the rate of return calculated as a result is called the external rate of return, and we are using now the return on invested capital approach, ROIC. Now this approach is extremely simple. It's not extremely simple. It's a contradiction. It's not that simple. But if you take it step by step, the chances of you making mistakes is actually minimal. Okay, so how do we proceed? Let's focus on the formula. Okay, so the formula says the future value is of course the previous value, and you multiply it, you compound it for 1 year. Okay, and how do I do that? So for example, my task would be to, and let's see, I have to use investment rate if the cash flow is more than 0. Means if the cash flow is positive, I have to use the investment rate. But if the previous cash flow is negative, then I have to use the ROIC, which is a required rate. We have to calculate that, but I'll use the return on invested capital rate. Okay, so let me repeat it again. If the previous cash flow is positive, I will use investment rate. So for positive, investment rate. Okay, for negative, it is ROIC. Okay, so let's take it step by step. So my task is to compound individual numbers one by one. So I have to compound this $8,000. How do I compound it? It is $8,000 into 1 plus. Okay, since this is a negative number, so I will use the ROIC. In this case, let's say it is I double prime. Okay, so I compounded this minus $8,000 for 1 year. Okay, and then I have to add these two. Okay, and then I use again the same criteria. If this number in the square, if it is negative, I will use ROIC. If it turns out to be positive, then I will use my investment rate. Okay, so whatever the number is, then I have to compound it again for 1 year. Okay, so I have to compound each and every number one by one, keep on adding. Okay, and same criteria. If it is positive, use the investment rate. If it is negative, use ROIC. Okay, so this one, finding a solution with, let's say, with your hands, like interpolation or any technique, it is very extremely challenging actually. So what we could do, we could use spreadsheet. Okay, and then we can use some formulas. So let's do that. It's very interesting. It's not challenging, but it is very interesting. Okay, so let me go back to my Excel sheet. Okay, let me enlarge it a little bit. All right. So this is my original cash flow. And what I'm trying to do is the follows. Okay, so please pay attention. Okay, so I will take this number as is. Okay, and all formulas starts with equal sign. Okay, and then I'll start with if. It's logical. If this number is greater than 0, okay, use this number multiplied by 1 plus the investment rate. If it is positive, use the investment rate. Okay, and then add this cash flow at t equal to 2. If not, then what you should do, use this number, but now this time use actually the ROIC rate. Okay, and again add this number. Okay, now I have to make few adjustments. For example, since I'll be using the same investment what's this called, the investment rate all the time, I have to lock this cell. Okay, so lock this cell. And lock this cell as well, and I'm manually locking it. Okay, press enter. Sorry. I have to lock this as well. So lock. Okay, then what I can do, just copy it down. Okay, now let me double click anywhere. So let me double click here. As you can see, the if condition is applied on this C8. Okay, so if my previous cash flow is more than 0, multiply it with the investment rate. Use the investment rate in compounding. But if it is otherwise, which means that if it is less than that, then use the ROIC, which is E2. It is straightforward. Now my task is, as you remember from definition, that IRR by definition is the rate at which, one of the definition is at which your FW is 0. So this is my combined FW, this C12. Okay, so let's use my solver. Okay, my solver. So set objective C12 equal to 0 by changing E2. Okay, solve. Okay, and as you can see, this FW turns out to be so close to 0, but since it's an optimization tool, it doesn't result into exact mathematical solution. But as you can see, my solution is 3.78. This is the way you find out the ROIC. Okay, again, it's not technical. Start with a number, decide whether it's a negative number or positive number. If it is negative, use ROIC. If it is positive, use investment rate. Finding a solution with your hands, it would be difficult. It would be close to impossible. So I would suggest use your Microsoft Excel. Okay, let's move forward. Now section D. Section D says, enter the cash flows into a spreadsheet and use the IRR function to find the I value. You should get the same value as the ROIC in part C. Okay, so let's do that. I already have all the numbers here. So instead of going through what's this called? Instead of using either ROIC or the investment rate, let's calculate the IRR directly. Okay, so IRR, double click and then choose all the cash flows. Okay, and let me provide a guess of 1%. Okay, enter, and as you can see, it is exactly the same 3.78. Now the question says, why is it so? Okay, why is it so? The reason is, since the sign, these cumulative FWs, which is like this column, it does not change any sign. Okay, as you can see, everything is negative. Okay, if it doesn't if everything is negative, it means that I'm using ROIC all the time. Okay, so that's why my ROIC and IRR are exactly the same. Suppose if there is one positive number, then of course my ROIC would have been different than IRR. Okay, so that's the logic behind it. Since all the future worth of the cash flows is negative, so my computer is using ROIC all the time. Because remember, for positive, we are using investment rate. For negatives, we are using ROIC. So that's why my IRR and my ROIC are exactly the same. All right, let's move forward. Problem 7.52. Okay, let's read the problem. Due to a significant troop buildup at the local military base, a school district issued $10 million in bonds to build new schools. The bond coupon rate is 6% per year, payable semi-annually, with a maturity date of 20 years. If an investor is able to purchase one of the bonds that has a face value of $5,000 for $4,800, what rate of return per 6 months will the investor realize? Assume the bond is kept to maturity. Okay, so everything in the red is the information that we would like to use in our analysis. Okay, this $10 million is none of our concern. So a municipality is trying to raise $10 million through bonds. Okay, one of the investors bought a bond whose face value was $5,000. Okay, but the investor paid only $4,800. So actually the bond was sold at a discount. Okay, so what is the rate of return for this investor? Let's do that. Straightforward question. So my face value is $5,000. My coupon rate is 6%, and it is compounded. Sorry, the coupon is paid twice in a year, so that's why C is equal to 2. Okay, so by using the formula, my coupon is 150, and it is straightforward again. So the way investors make money out of a bond is through number one, coupon, and number two, the market price. Okay, so the way coupon works, if the face value of a bond is 5,000, and if the coupon attached to that bond is 6%, okay, so per year the coupon payable to the investor is $300, but since they are paid semi-annually, so per 6 months, every 6 months, the investor is getting $150. Now this is the cash flow diagram for the investor. So the investor, as you can see, invested $4,800. So that's why it is with a negative sign. But the investor is now getting for $150 after 6 months. Okay. The bond's maturity, as you remember, was 20 years. Okay. So that's why there are total of 40 periods in this cash flow. Okay, so let me summarize it for you again. The investor paid $4,800. The investor is getting $150 after 6 months. Okay, and then at the end of the 40th payment, okay, the investor is getting 150, but he or she also gets 5,000, which is the face value of the bond. Okay, so this is the equation that we use in order to calculate the internal rate of return. Okay, or in bonds, actually in finance language, they also called it yield to maturity, YTM. Okay, or rate of return, whatever. Okay, so the investor invested 4,800. Okay, this is what the investor is getting for 40 periods. Okay, 150. Okay, and that investor is also getting $5,000 at the end. Okay, so I have to calculate the present worth of this 150 annuity by multiplying it with PA factor, and then I have to calculate the present value of the future, $5,000. Okay, my problem is which rate should I use? I don't know that. That is actually what I'm required to calculate. So this is the way I do it. Okay, if you do not have access to a computer, of course you have to do it through trial and error method, interpolation. Okay, in trial and error method, you start with the first trial. And how do you choose your first trial? Okay, let's do that. So let's ignore the time value of money, and let's see how much these $150 and this another positive cash flow. So bring all positive cash flows together. Okay, so 150 multiplied by 40, which is $6,000, and if I add it with $5,000, it's like $11,000 at the end of 40th period, at the end of 20 years. Okay, so what rate will actually make $4,000 into $11,000, okay, for 40 periods? Okay, so their trade, if I solve for I, is 2.09. But the factor tables are only for 2%, 3%, and 4%, so on and so forth. So my first try would be 2%. Okay, I get these factors from the factor tables. Okay, the PF factors and the PF factors, and at 2%, my PW is 1567.83. But remember, the yield to maturity or the rate of return or the internal rate of return is one at which your PW is equal to 0. So my target is this one, PW equal to 0. So let me try, sorry, apologize, this is a mistake. So at I equal to 4%, okay, if I get factors for 4%, now my value PW is minus 789.59. Okay, so of course 0 would be in between 1567 and 789. This is what I want. Interpolation at 2%, my PW was 1567. 4%, it is minus 789.58. Okay, if I would like to calculate, let's say I star, okay, this is the rate at which your PW equal to 0. You do the interpolation and your X is 1.33 and your calculated yield to maturity, or let's say rate of return for the investor, is 3.33%. But if I use Microsoft Excel, it's 3.18. Again, interpolation, it's a linear technique. The relationship between PW and I itself is non-linear, so there will always be a degree of error. Okay, so that's perfectly fine, that is acceptable. Okay, let me try to calculate this number, this 3.88 through Microsoft Excel. So how do I do that? Okay, so as you can see, this is the cash flow diagram, and the cash flow would look like this. At t equal to 0, the investor invests. Let me enlarge it for you. So the investor invests $4,800, so that's why it's a negative with the negative sign, and then he or she is getting $150 after 6 months. Okay, and then as you can see, at the 40th at the end of 20 years, or the 40th payment, the investor is getting $5,000 back, which is the fast value of the bond, and another coupon, which is $150. So that's why the total amount here is $5,150. So this is the way you calculate IRR. So IRR, double click on IRR. Okay, it says values. So let me provide the range for the values. Okay, so I choose all the cash flows. Okay, and then I provide a guess number, let's say 1%. Okay, you can provide any guess, that's not a problem. Okay, it's 3.18. Okay, so straightforward, nothing technical. I would seriously recommend, please do not attempt finding out the rate of return for the investor only through Microsoft Excel. Okay, because whenever you are doing it through your hands, you are actually internalizing the concept. You understand the concepts better. Okay, so I would recommend that you do it with your hands first. All right, problem 8.30. Okay, so this problem is from chapter number 8. Chapter number 8 was all about multiple alternatives. Okay, and in multiple alternatives, what we do, we are interested in incremental cash flows. Why? Because if there are more solutions for IRR, in order to remove what's this called, those solutions, in order to, let's say, tackle the issue of multiple IRRs, we calculate the incremental cash flows. Okay, so let's do that. Xerox iGen X high-speed commercial printers cost $1.5 billion to develop. The machines cost $500,000 to $750,000 depending on what options the client select. Spectrum Imaging System is considering the purchase of a new printer based on the recent contracts it received from printing weekly magazines and mail out advertising materials. The operating cost and the revenue generated are related to a large extent to the speed and other capabilities of the copier. Spectrum is considering the 4 machines shown below. The company uses a 3 years planning period and at an MARR of 15% per year. Determine which copier of the company should acquire on the basis of an incremental rate of return analysis. Now forget about these in the first information provided in the first 2 lines. Okay, the information relevant to this problem is that the Spectrum company got a contract, and it's a huge contract, printing contract of a weekly magazine. So they would like to buy a printing machine. Okay, the initial investment of iGen 1 is $500,000. The operating cost is $350,000, but the annual revenue would be $450,000. The salvage value would be $70,000. Similarly, for iGen 2, the initial investment is $600,000, operating cost is $300,000, and annual revenue is $460,000. Salvage value is $85,000. So as you can see, if the company is investing more and more, it is becoming more and more efficient in terms of cost saving, okay, and it is generating more revenue. So revenue is increasing. Okay, so of course only then it will make sense to buy a more expensive machine. So let's find out whether these out of these machines, which machines make more sense. Okay, let's do that. Now these are the net cash flows. Okay, so the initial investment of iGen 1, as you remember, was $500,000. The revenue minus cost per year is $100,000. How? Because it is 450 minus this 350. Okay, so the total is 100,000. So that's the net cash flow. Okay, 160, 205, and 310. And lives is, they're considering actually 3 years life for these printers. Now, in multiple projects evaluation, we always start by ordering all the alternatives. Okay, and as you can see, iGen 1, iGen 2, iGen 3, iGen 4, okay, they are ordered, okay, from high to low. No, sorry, apologize, from low to high. Okay, so 500,000 cost, 600,000 cost, 650 and 750. Okay, so that's step number 1. Step number 2 is compare the cheapest project with do nothing. Okay, so this project with this project. Okay, let's do that. So if I compare iGen 1 with do nothing, the incremental cash flow, which is this number minus this number, this number minus this number, so it will be exactly the same cash flows. Okay, and once I calculate the IRR, okay, how do I do that? I'll show you actually on Microsoft Excel. Again, super easy. Okay, the IRR is 12.6%, and it's with minus sign. So since it is less than MARR, we reject project iGen 1. So it's not worth to buy this kind of a printer. Okay, so DN is selected for the next round. Okay, so in the first round, the winner is DN. Okay, second round, I compare. Now DN is Defender and this one is Challenger. Okay, again I calculate the incremental cash flow, okay, which is this number minus this number, okay, and the IRR of the incremental cash flow is now minus 2.74. Again, it is less than MARR. Okay, so reject iGen 2. Okay, so this printer is also not worth it. Okay, so the winner of this round is again DN. Okay, so I compare again DN with the third printer. Okay, I calculate the incremental cash flows again, and when I calculate the IRR for incremental cash flows, it is again less than MARR. So reject again IGN 3. So the winner of this round is DN again. Do nothing. Okay. Now I compare do nothing option with the fourth printer. Okay. Once I calculate the incremental cash flows, the IRR of incremental cash flows now is 17.77%. Okay, and apologize, it is greater than MARR. Okay, it is greater than MARR. Okay, so that's why we accept printer number 4. So the company, this decision is what? Decision is company should buy iGen 4 printer. Okay, now how do we calculate these numbers, the IRRs? Straightforward. Let's go back. Okay, so 8.30 incremental. Okay, so let's calculate. Let me enlarge it a little bit. Okay, so let's calculate incremental cash flows. So incremental cash flows is equal to this one minus this one. So IGN 1 minus DN. So this is for actually IGN 1. Let me write it down. In fact, let me copy it from here. So copy, and then I have to paste it here. Okay, IGN 1 minus DN. Okay, so as you can see, the printer initial cost is $500,000, and then the net cash flows, which is revenues minus the cost, is $100,000 for 3 years. So $100,000 here, $100,000 here, and then it's 170. Why? Because $100,000 is the annual revenue, net revenue, plus $70,000 is the salvage value. Okay, now let's calculate the IRR. So equal IRR, double click on this one, choose all cash flows, comma, provide any guess. Let me not provide any guess, because if you do not provide any guess, it starts with 10%. Okay, so let's do that. It's minus 13. So let me increase the decimal points. Okay, and as you can see, it's 12.60. Now for IGN 2, so IGN 2 minus DN, because DN is the winner. Okay, for IGN 3, let me calculate all the differences first. So IGN 3 minus 0. Okay, and IGN 4. So IGN 4 minus okay. I recommend whenever you copy formula, always click at some random place and see whether everything is done correctly. And I can see that everything is done correctly now. Okay, because in the process of copying the formula, sometimes if you do not log the proper cell, okay, it actually messes up with the formula. Okay, so I have already calculated IRR here. So what I can do, I can just drag this formula to the right. Okay, and as you can see, it calculates the IRR right away. Everything like the first three, printer 1, printer 2, printer 3, the IRR of incremental cash flows is less than MARR, which was 15%. So these printers do not make any sense. The only printer which makes sense is this iGen 4. Okay, straightforward problems, nothing technical. In multiple project evaluation, what you do, you always do pairwise evaluation. Okay, in this particular example, in the first 3 rounds, okay, it's a coincidence that every time DN was the winner. The only time the DN was loser when I compared it with iGen 4, the 4th printer. There may be situations once you compare projects in the first round, okay, you choose one, and if you contrast that project in the second round, okay, maybe the other project is a winner. Okay, so please try some chapter and problems. If you're facing any problem, I'm just one email away. I wish you all the best. I will record another lecture and I will share that one with you as well. So take care and have a wonderful day.